Translate this picture right here, 5 units right and 1 unit up. All right, so this is a translation. It's a transformation where all I do is take a shape and move it somewhere else. I don't rotate it, I don't flip it, I don't reflect it. It's just I take this shape and go. So let's do this. Just because you might have a teacher that shows you this type of notation, I can write this guy out as if I'm moving it 5 units right, you take your x and you add 5. Taking your x value and adding 5 means you're moving it to the right. Subtracting a number means you're moving it to the left. Since I'm moving it 1 unit up, I'm going to say y plus 1. Plus 1 means I'm moving up. If it was minus a number, I'd be moving it down. Was it necessary for me to do that? No. But if you have a teacher, if your book is like, instead of giving you words, if it says translate according to this thing right here, well, that's what it means. Right 5, up 1. So let's move our shape. And just to be extra sweet, I'm going to list out the points when I'm done. When you move a shape, the best thing to do is you move it 1 point at a time. So it doesn't matter which one you start out with. I'll start out with T. 5 right and 1 up. So here's T, right 1, 2, 3, 4, 5, go 1 up. And when you label it T prime. That little apostrophe tells you that we have taken an object and moved it. The object before you move it is called a pre-image, and the object after you move it is called the image. All right? So before I write out what all these are, let's do the rest of these. So I'm still going one at a time. Go right 1, 2, 3, 4, 5, up 1, put a dot there, call it G prime. Go to B, go right 1, 2, 3, 4, 5, go up 1, put a dot there, call it B prime. And then, of course, I'm going to do my best connecting these dots, knowing very well that this is my greatest weakness, and I'm doing all right, baby. Now, the shape didn't change. It didn't get bigger. It didn't get smaller. It didn't flip. It didn't rotate. When I translate, all I do is move it. So here's my pre-image. Here's my image. Let's list out our new points in no particular order. G prime has me starting at the origin, going right 1, 2, don't move up or down. So right 2, don't move up or down is 2, 0. T prime, not to be confused with T-pain, is I start at the origin, go right 1, 2, 3, 4. Don't move up or down, so 4, 0. And B prime has me starting at the origin, go right 1, 2, go down 1, 2, 3, 4. So right 2, down 4 is negative 4, and those are the points of my image. So again, translating says, let's just move a shape, don't do anything fancy. When I'm done, if you have to list out the points, there they are. Pretty simple. Describe the transformation. So I have two shapes here, a blue and a black, or a black and a blue, which is what you're going to be when I'm done with you. I'm just kidding. Please don't notify me. I have to figure out which one is the original. Is the black triangle the original, or is the blue triangle the original? Well, if you look very closely, the blue triangle has little apostrophes on them, which means the original, also known as the pre-image, is the image in black. So I'm going from the black triangle to the blue triangle. I'm going to give this in two answers. One answer in words and one answer in notation form. And if you're wondering, why both? Do we have to do both? Nope, but I don't know what your teacher's going to have you do, so I'm going to make sure I have it written out in both ways. So we pick a point, doesn't matter which one, we pick a point and see what happens. I'll start at Z, and in order to get from Z to Z prime, I go right 1, 2, down 1. So right 2, down 1. That's one way that you can write this out using words. And many teachers would be like, perfect, good, you're done. Or you might have a teacher that says, nope, write it out like this. All right. Well, write 2 is if you're going left or right, you use your x value. And right 2 is in the positive direction, so we add 2. If it was left 2, we would minus 2. If you go up or down, that's the y value. And down 1 is minus 1. Up 1 would be plus 1, but since this is down, this is minus 1. So again, 2 answers that are exactly the same. I wrote them both down so that you can see what they both look like, just in case you have a teacher that forces you to do one instead of the other. But that's how you describe a transformation. And in this case, this was a translation from one shape to its image. Rotate 90 degrees clockwise about the origin. Rotate. That means we're spinning things around. In this case, we're spinning it around clockwise, which goes like a regular clock goes like that. When you spin something, usually, not all the time, but usually you either go 90, 180, or 270. 90 is 1/4 of an entire circle. So it's important that we know that 90 degrees is 1/4 of the spin. Now, this is the way that I've been doing it for years, and you might have a teacher that does it differently, but this is what I do. I'm pretending that I'm using a piece of paper and I'm physically spinning it this way 1/4 of a turn. So I take my paper, and in this case, I take this guy and I spin it 1/4 of a turn, click. My answer is going to look like a shape that looks exactly like that. That is my answer. So what I'm going to do is I'm going to write out these points as they appear so that when I fix my page or picture, I can draw those points out and I have a nice pretty little picture. All right, so let's find out what these points are. In no particular order, I can start out with I, so I'm going to call it I prime, and I find out what I prime is as it appears. And if I start at the origin, it appears to be left 1, 2, up 1, 2, 3. So left 2 is -2. Up 3 is +3, so I prime appears that it would be at left 2, up 3, -2, 3. Do it again. Here's E. So E prime looks like I go from the origin left 1, 2, 3, up 1, 2, 3. So left 3, up 3. X appears to be left 1, 2, 3, 4, 5. So X appears to be left 5, don't move. Left 5, don't move, so -5, 0. And Q appears to be 1, 2, 3, 4, down 1, 2. So -4, -2. Now, this is what my answer is supposed to be like. So if your teacher says, take the original picture and rotate it 90 degrees clockwise, you can't just spin it and say, here, teacher, look, this is what I ended up with. No, we spun it so that we could see what our answer will look like. We write down the coordinates as they appear so that what I can do next is spin it back to its regular position and draw those points out. All right, so let's do that. Let's draw those points out. I was -2, 3. So I prime is going to be left 1, 2, up 1, 2, 3, put a dot, call it I prime. E prime has you going left 3, up 3. So left 1, 2, 3, up 1, 2, 3. That's E prime. X prime has me going from the origin, moving 5 to the left, and then don't move at all. So 1, 2, 3, 4, 5, don't move at all. And Q prime has me going left 1, 2, 3, 4, down 1, 2, right next to my original I. So this was my pre-image. And now what I'm doing is I'm connecting the dots to make my regular image. And I'm always so bad at this. Let me try this one again. So bad at that. No, not happy. No, not happy. So if you had oh my gosh, not happy at all. So if you had the capacity to draw like a normal person, unlike me, you would realize that, oh, these shapes are exactly the same. They didn't change at all. No, they didn't. What they did is they rotated, and this guy spun 1/4 turn that way and looked like that guy. So that's how I do rotations. Take your page, spin it in the appropriate direction, write down the dots as they appear, fix your page, and draw out those dots, connect them better than me, and you're done. Rotate 90 degrees counterclockwise about the origin. All right, so when we take a picture and we rotate it, we have to first care about our direction. Counterclockwise is the opposite of clock. Clock go this way, so counterclock go that way. 90 degrees tells you how much you turn. So the whole spin would be 360. So 90 out of 360 is a quarter of a turn. 180 would be a half a turn, in other words, upside down, and we don't care about the direction there. 270 would be 3/4 of a turn, but here we have 90. So the method that I do is I take my picture, or in your case, you would take your page or the page that you're working on or the printout that you're working on, and you literally spin your page in this direction 1/4 of a time. And what that looks like is you take your paper and you lay it sideways in this specific direction. So my answer is supposed to look like this triangle quadrilaterally looking thing standing up. I know my answer is supposed to look like this. So what I'm going to do next is I'm going to write my points as they appear. So it's good that I don't have numbers on here so the negatives and positives don't throw me off. This A appears to be to the left and up. So I'm going to write out my prime as if I'm going to the left and then up. So let's get specifics. In order to get from the origin to A, I go left 1, 2, 3, up 1, 2, 3, 4. So A prime is left 3, up 4. -3, +4. In order to get to D, I go from my origin left 1, 2, 3, 4, 5, up 1. So D prime was left 5, -5, up 1, +1. In order to get to M, I go left 1, 2, 3, 4, 5, down 1. So M prime is left 5, down 1, -1. And to get to W, I start at my origin and I go left 1, 2, 3, 4, and go down 1. So W prime is left 4, down 1. Now that I know what my picture is supposed to look like, I can take my picture, my page, whatever it is that I'm working on, and put it back to normal, knowing very well that my answer is going to live somewhere around there. So let's draw these points out. I have A prime, which was -3, 4. So A prime, start at the origin, is left 3, up 4. There's my A prime. So I'm starting to build my new image. That's my pre-image. Here's my new image. D prime is left 5, up 1. So I'm going to go left 1, 2, 3, 4, 5, up 1. That was D prime. M prime was -5, -1. In other words, left 5, down 1. So M prime is left 5, down 1, M prime, and W prime is -4, -1. 1, 2, 3, 4, 1. W prime. And now, of course, the part that I'm awful at, you connect the dots so you can see clearly that this is the exact same shape that you originally had, just, flipped around a bit. That looks awful. But what we have is this guy spun 1/4 of a turn. My shape, if I could draw better, doesn't change, doesn't get bigger, doesn't get smaller. It just spins around. Spins a right round, baby. It's from a song. But that's how you do rotations. You find out the direction, you take your paper, you spin it however many times you're supposed to, you write your points out as they appear, you fix your paper, you plot those points out, connect the dots, and then you can see you have the same exact shape, just rotated around somewhere. That's how rotation is done. Describe the transformation. All right, so first things first, I have to find out what the original picture is and what my new picture is. Well, it looks like the blue guy here has apostrophes attached to them, which means the black guy is my original, also known as the pre-image. Now, I didn't just take my shape and moved it. I didn't just take my shape and reflect it, so this is clearly a rotation of some kind. Now, when I describe a rotation, I have to do two things. Give the direction and how many spins it took. So we pick one letter, and notice that K used to be left 1, up 3, and K is now right 3, up 1, which means I went in a clockwise direction, and since I only spun it 1/4 of a turn, I rotated clockwise 90 degrees. Now, some of you might be saying, whoa, buddy. What if I took K and went one quadrant over, another quadrant over, and a third quadrant over, but I went counterclockwise? Yeah. What if I did that, and since it's 3 spins, I wrote down 270? Who's wrong now? Neither of us. We're both right. There's two possible answers here. Spinning 90 degrees clockwise is the exact same thing as spinning 270 counterclockwise. So either answer is acceptable. You just have to make sure that you get the right number down for the direction that you're going. But that's it. That's how you describe this rotation right here. Reflect across the y equals -2 axis. All right, usually I reflect over like the x-axis or the y-axis, but this has me building a brand new mirror. Y equals -2 means I'm going to have a horizontal line that goes through -2. So let's go to the y-axis, since it's y equals. Let's go to the y-axis and go down to -2. There you are. And build my mirror. Now what I'm going to do is reflect this guy up here. The best way to do reflections is, now that we have our mirror drawn out, you take each point, each letter, and find out how many spaces our guy is away from the mirror. So Q, for example, is 1, 2 units away from the mirror, which means Q prime is going to appear 1, 2 units away from the mirror. Q prime. All right? I guess that's an X. Maybe, I don't know, maybe it's an L, maybe it's a Z, I can't tell. Let's call it a Z. It looks like a Z now that I look at it closely. So you're a Z now. Z appears to be 1, 2, 3 units away. So 1, 2, 3 units away, Z prime. I seems to be on the mirror, so don't move it. Okay, that's allowed to happen. And E appears to be 1 unit away from the mirror, so E prime is going to be 1 unit away from the mirror. And now the part that I'm always terrible at is drawing this guy out. Oh man, why is it so far away? That's not too bad. It's not too bad either. Maybe I'm finally getting better at this. So there you have it. There it is. There's our reflection. You can see that this guy is completely reflected. Just get some bonus points and get some more time added to this YouTube video so I can get a little bit more money. We're going to list what these 4 points out. In no particular order, I prime. Now, I measure my prime points from the original origin, not from like this green line or anything like that. So my origin is right there. And in order to get to I prime, I go left 1, 2, 3, down 1, 2. So I prime is left 3, -3, down 2, -2. E prime was start at the origin, go left 1, 2, 3, go down 1. So E prime was left 3, -3, down 1, -1. Z is going to be start at the origin, go nowhere left or right, and up 1. So Z prime is nowhere left or right, up 1. So 0, +1. And Q prime has me starting at the origin and going right 1, 2. Don't move up or down, stays glued to the x-axis. So that's how you reflect across a specific axis. In this case, y equals -2 has me take the x-axis, shifting it down 2, but I still see my beautiful little reflection right there. Looks good. I'm sticking with it. Reflect across the y-axis. My y-axis is right here. So what's going to happen with this picture is I'm going to reflect inside of a mirror. So basically what's going to happen is whatever shows up over here is going to be opposite over here, and whatever shows up on the left is going to be opposite over here. So there's going to be a little bit of sloppiness, but that's okay. The y-axis is my mirror, so I'm going to draw a line on the y-axis acting as my mirror. I'm going to draw it all the way down, even though it's not necessary. All right, there you go. The best way to do a reflection is you take each point one at a time and find out how far away it is from the mirror. So let's start with A because it's kind of like the clearest one that I can use. A appears to be 1, 2, 3, 4 units away from the mirror. So let's graph it 1, 2, 3, 4 units away in the opposite direction and call it A prime. Let's do it again with the other letters. We're going to run into each other. That's okay. W is 1 unit away from the mirror. So W prime is also going to be 1 unit away from the mirror. D is 1 unit away from the mirror. So D prime is also going to be 1 unit away from the mirror. And M is 1 unit away from the mirror. So M prime is also going to be 1 unit away from the mirror. So we take that, we connect the dots the best that we can. And as you can see, we have the exact same image, just kind of flipped. Not flipped, reflected. I like to view these as when my art teacher wanted to be lazy in grade school, they would give us all pieces of paper and say, put a bunch of paint on the paper, fold it in half, and open it back up, and you have a butterfly. That's kind of like what we have here, a butterfly or angel's wings, whatever your religion is. Now, what I'm going to do is I'm going to list what these points are, just because you might have a teacher that asks you to. So D prime, I'm going to go to my origin, and the way I get to D prime is I go left 1, up 1, 2, 3, 4, 5. So D prime was left 1, -1, up 5, +5. A prime has me starting from the origin and going left 1, 2, 3, 4, and up 1, 2, 3. So left 4, up 3, that's A prime. Ooh, I'm going to avoid a curse word and put W next. I know it's spelled differently, but you never know who's watching these things. Start at the origin, go right 1, up 1, 2, 3, 4. So right 1, up 4 is W prime, and M, I wish it was a G, it could be dog. I go right 1, up 1, 2, 3, 4, 5. Right 1, up 5. And that's reflecting. Dog. Dom. Reflect across x equals y. Reflect across y equals x. This is hard for me to do visually, but I'm going to try my best to do this. Okay, I'm going to draw out the y equals x line, and as you can see, I screwed that up already. Now it's not looking so bad. This green, perfectly straight line is supposed to act as a mirror. So if you could take your head, so this is your head, and tilt it sideways just a little bit and pretend that it's lining up with that green line, you are going to see that this shape is going to flip over it. Now, it's hard for me to kind of line things up and find out where these points go. I know from regular reflections that I always count out how many dots I am away or how many units I'm away from the graph or from the mirror, and I just graph it on the other side, but that's hard to see. What I have here is y equals x. So this is what I'm going to do. This is a trick. Y equals x and x equals y. Let me list out my 4 original pre-image points. This might seem a bit too much and gratuitous, but I guarantee you, if there's anything I'm not, it's gratuitous. L, the original L, is don't move, go up 2, so the original L is 0, 2. The original H is left 2, up 1, 2, 3, so the original H is left 2, up 3. The original Q is left 2 and up 1, so the original Q is -2, +1. And the original P is left 1, 2, 3, down 1, 2, so the original P is left 3, down 2, -3, -2. What I need to find is clearly not these guys, but these guys. The points of the image, the reflection points. How am I going to pull these off without using my graph? Well, I'll tell you. If you look at the original equation that we're given, y equals x, this is telling us that y equals x now and x equals y. What does that mean? These guys just flip. 0, 2 becomes 2, 0. -2, 3 becomes 3, -2. -2, 1 becomes 1, -2. And -3, -2 becomes -2, -3. All I did was flip the points. I take these guys and graph them out. L prime, let's go to my origin, is right 2. Don't go up or down, L prime. H prime is right 1, 2, 3, down 1, 2. Put a dot there, H prime. Q prime is go right 1, go down 1, 2, Q prime. And P prime is -2, -3. So go left 1, 2, go down 1, 2, 3. That's P prime. Now for me, I struggle mightily with graphing these. So I'm going to notice that, all right, well, H connects to Q, so H prime is going to connect to Q prime. Q connects to P, so Q prime connects to P prime, okay. P connects to L, so P prime connects to L prime. Sorry, Q prime. And then last but not least, L connects to H, so L prime to H prime. So again, if you take your head and you tilt it about 1/8 of a turn, you could see the mirror image, how this guy reflects to that guy, that these guys, if I knew how to draw, would be the exact same shape, and this guy is just a reflection of that. Okay? Not easy. But the y equals x trick is just that. It's a trick, and it's meant to make life a little bit easier if you know the trick. And now you know it. Describe the transformation. All right. Well, I have three types of transformations. I have a translation, which means I just move things. So T goes up and right. U doesn't, so it's not a translation. A rotation has me rotate things, but nothing's rotated. It looks like it's just a mirror image, because it is. My job is to find out where the mirror would be. Well, it's hard to see, but the only way that you can get this black shape and this blue shape on top of each other and have it share a side is if the mirror was the side. So my mirror is this guy right here. And have that going on is going to look like this. So my reflection, my mirror is not the x-axis, it's not the y-axis, it's this red line right here. What is the equation for that red line? Well, y equals mx plus b, where m is my slope, b is my y-intercept. It appears to me that my slope is up 1 over 2, and it's negative, so my slope is negative 1. It also appears to me that my y-intercept is nothing. So putting that all together, I get y equals slope of negative 1x plus nothing, sloppy, y equals negative x. Kind of weird, but y equals negative x is my mirror. It's the only way it works. Translate 4 units right and 1 unit down, then reflect across the x-axis. All right, let's translate it first. Let's write out our points and then reflect it and write out our points again. I'm supposed to go 4 to the right and 1 unit down. So let's go 1 point at a time. Let's start with F. F is going to be 1, 2, 3, 4 to the right, 1 unit down, F prime. Go to the next point in no particular order. G is going to be 1, 2, 3, 4 to the right, 1 unit down, call it G prime. And Y has me going 1, 2, 3, 4 to the right, 1 unit down, Y prime. Let's list out those points. F prime. Starting from the origin, the way I get to F prime is I go left 1, up 1, 2, 3. So left 1 is negative 1. Up 3 is positive 3. Okay, G prime has me starting at the origin, not moving left or right, so that's 0, and having me move up 1, so 0, negative 1 is G prime. Y prime, let me make that dot a little bit bigger, you'll see why in a minute, is I start at the origin, go left 1, don't move up or down, so Y prime is going to be left 1, don't move up or down. So this is my first image. This is my first transformation. Okay, bada bing. My second transformation now has me reflecting it across the x-axis. So I'm going to draw my mirror. That's why I made that big. I'm going to draw my mirror across the x-axis. Now, when you reflect an image, you take a point, find out how far away it is from the mirror, and write it out that many units away on the other side. So if I take G prime, for example, and notice that G prime is 1 unit away from the mirror, I'm going to write out its image 1 unit away. I'm going to call this G double prime because it's my second image. F prime is 1, 2, 3 units away. 1, 2, 3 units away is F prime. Y prime is living on the mirror, which means Y prime and Y double prime are exactly the same. Connect the dots. Connect the dots. And you can see we have a reflection. So let's write those points out. F double prime, just to stay consistent. If I start at the origin, F double prime appears to be left 1, down 1, 2, 3. So left 1 is negative 1, down 1, 2, 3 is negative 3. G double prime appears to me I don't move, but go down 1. So 0, -1. F double prime has me going, I already did F double prime. Y double prime has me going left 1, don't move. So -1, 0. As you can see, when I reflect over one of the axes, not much changes except for the Y value in this case is now negative. Or the opposite, I guess I should say. That's just a fun little shortcut if you memorize stuff like that. But this is me doing 2 transformations in one coordinate plane. Awesome. How many lines of symmetry does this shape have? What is a line of symmetry? It's a line that you can draw that cuts the shape exactly in half, where the left side and the right side are exactly the same. So when you have regular polygons like this, you should be able to look at this and be like, I should be able to cut this completely in half just like that. You can. So one way of cutting a regular shape into 2 equal sides where the left and the right are exactly the same is you go through the midpoint of opposite sides. So we do it again. We do it again. And so far, if I focus on the sides, I have 3 lines of symmetry. But as Beyonce once said, we're not done. Because if I focus on the vertices, the corners, I can also cut my hexagon in half like so through the vertices. So if I look to the left side of that, it's exactly the same as the right side of that. So when I have regular shapes like this one, I not only cut through the sides, but I cut through the vertices as well. So I can cut through you, and I can cut through you. And what I end up here with the vertices is I have 3 more. So my total amount of lines of symmetry is 3 plus 3. Let me get out my calculator, carry the 1, divided by 1,000,000,000. 6. Look at that. It's a patriotic hexagon. I love it.